To get started, can you identify which of these numbers does not have a real square root? Exactly. Negative numbers, like -1, don't have square roots. You might guess the square root of -1 is -1, but squaring -1 gives you +1. And if you square +1, you still get +1. So then what number squared gives you -1? Well, we said this equation has no real solution. So about 500 years ago, mathematicians invented a solution, I. I is short for imaginary unit. I is defined as being the number whose square is -1. You can't write it as a fraction or a decimal because it's not a real number. It's just I. So because I squared equals -1, you'll often see I also defined as the square root of -1. This makes sense, right? But as you'll see in a later lesson, sometimes you have to be very careful with this definition. Okay, so let's try some examples. Suppose you have 2i, which is the same as 2 times I. And now let's say you're multiplying that by another 2i. Can you evaluate this product? Remember, when you're multiplying numbers together, you can multiply them in any order without changing the answer. So we can rearrange this product as 2 times 2 times I times I. So using the fact that I times I, or I squared, equals -1, evaluate this product. Excellent! So 2 times 2 is 4, and I times I is -1. So this product is -4. So you could say that the square root of -4 is 2i, because 2i multiplied by itself gives you -4. Okay, so try another example. How would you evaluate this expression, the square root of -9? Exactly. So if you square 3i, you'll get -9. Do you see a pattern? To evaluate these square roots of negatives, you took the root of the positive number and then multiplied by I. So let's look at another example, the square root of -7. If you were asked to simplify this, then you'd say I times the square root of 7. Let's double check that. If we take I times the square root of 7 and square it, so we're multiplying it by itself, what do we get? Well, we can reorder the terms so it's I times I, and then times root 7 times root 7. I times I is -1, and root 7 times root 7 is 7. And sure enough, -1 times 7 is -7. So this is the correct answer. So then how would you simplify the square root of -13? Your answer should include the square root symbol. Nicely done. So you can write the square root of -13 as I times the square root of 13. This is the simplified expression. Next, let's look at the square root of -12. If you were to simplify this expression, a good start would be to write it as I times the square root of 12. And you can further simplify this by taking a closer look at the square root of 12. Remember how to simplify roots? Root 12 is the same thing as root 4 times root 3, and root 4 is 2. So I times the square root of 12 equals I times 2 root 3, and you can write it like this, 2i times root 3. So this is the simplified expression for the square root of -12. Try one more example and simplify the square root of -45 so that the number under the root is positive and has no square factors. Brilliant! So first you can write this as I times the square root of 45. Then you can simplify root 45, which has a square factor of 9. So your fully simplified answer is 3i times the square root of 5. Nicely done. To get started, go ahead and simplify the expression 2x plus 5x. Right, if you have 2 of something and then another 5 of it, that's a total of 7. So the answer here is 7x. You can simplify this the same way if instead of x you were to have I, the imaginary unit. So 2i plus 5i equals 7i. Try another example. What's 6i plus 8i? Exactly, 6i plus 8i equals 14i. Next, let's subtract imaginary numbers. What's 9i minus 3i? Well, if you have 9 of something and subtract 3, that leaves you with 6 of something, right? So 9i minus 3i equals 6i. So then what would you say is 13i minus 2i? Right, so 13i minus 2i is 11i. Now, what if we were to switch the order here? What's 2i minus 13i? Excellent, so 2i minus 13i is negative 11i. So yeah, imaginary numbers can have negative coefficients like this. Next, let's multiply imaginary numbers. If you have 3i times another 3i, you can multiply the 3's together and the i's together. 3 times 3 is 9, and I times I gives you negative 1. So this product is negative 9. Next, see if you can evaluate 2i times 7i. Right, 2 times 7 is 14, and the i's here make this product negative 14. Now, what if we didn't have this I over here so that we have just 2 times 7i? Can you simplify this expression now? Right, 2 times 7 is 14, and we have an I, so this product is 14i. Next, try evaluating a few more products of imaginary numbers, and notice that this time there are a few minus signs lurking around, so you'll have to be very careful. If you get stuck, feel free to ask for a hint. Nicely done. So this first product is positive 20 because the i's multiply to negative 1, canceling out this minus sign. And down here, the minus signs cancel out, leaving you with 2i times 8i, or negative 16. Finally, let's look at division. Suppose you have 14i, and let's divide it by 2. Can you simplify this expression? In other words, what can you multiply by 2 to get 14i? Right, this is just like simplifying an algebraic expression. 14 divided by 2 is 7, and then you have an I. So this quotient equals 7i. Alright, last one. This time we have imaginary numbers in the numerator and the denominator. What's 16i divided by 4i? Notice there's a common factor of I in the numerator and denominator that you can cancel out. Excellent work! The i's in the numerator and denominator cancel out, leaving you with 16 divided by 4, which equals 4.